They all work the same. If you do this on a calculator and you get the p-value, that's fine. If you don't do it on a calculator, I don't need you to look the p-value up separately. If it's there, use it. If it's not, use your critical values. So let's start and go over these. Okay. So this one, you had a claim of at least 94 pounds per year of this fruit used by people in the United States. So at least greater than or equal to. That's your claim. Make sure you label who's HO, who's HA. Shaded, reject HO. Not shaded, fail to reject HO. Find me your critical cutoff value, and if you do this, it's better if you give me where you got it from, because if, say it's a T, and you did the inverse norm, if I don't see inverse norm, I don't know where your number came from, so it's wrong. If I see inverse norm, I could at least say, well, it should have been inverse T, so I'll take off half of those points, and I'll work it through with your inverse T. If you use the calculator versus the formula, your answers are a little bit different than mine. So make sure you tell me where you got these from. Even on your inverse T versus your table, the answers are a little bit different. Give me your formula or calculator step, your test statistic. Show me if you're gonna do a decision. Show me where it fell, and give me your decision after that. Make sure you give me an interpretation, and don't stop at the word claim. Make sure I get the claim. For 20 points almost, that's a nice little problem to do. Can everybody do these? Everybody remembers these?
Those make sense. I think the ones that I forgot were like the ones with the percent.
Yeah, the proportion ones?
Yeah.
Yeah. I honestly can't remember if it's a proportion or a T. I know there's a Z. I know there's a 2. Yeah.
How can you tell if you're doing a Z test or a T test?
And unfortunately, this didn't come out on yours. The word population standard deviation. Apparently, I don't know, but your copy doesn't have this. I changed it from last year. A T. You probably did a T because it doesn't say population. And I no longer have the copy that doesn't have it, so I don't know where I printed it off from. I don't know where I printed it from, unless I printed an old one, but I did change quite a few of the problems, so I don't know what happened. And mine has it, but yours doesn't. That should say population standard deviation. That's what tells us that it's a Z-score. And if it talks about the sample, then it's a T. If it doesn't talk about any of your standard deviations, it's a P or a pi. Well, it's a P. Okay. This guy. All right, we did this one. This one is strictly from your samples. Once they start listing you how many in your sample space, that's your mean. That's your standard deviation from your sample. It's all in one sentence. So it's all pertaining to your sample. So you're going to do a t-test on this. Again, to find population standard deviation is a Z. Sample standard deviation is a T.
So on the test it's going to say population?
Or it's just going to say all together in the sample word. As soon as it says sample of N and it puts it all in the same sentence, that's everything to do with your sample. Using your T-table, guys, is probably the best to do for this because it gives you a one-tailed versus a two-tailed. You don't have to divide anything by 2 like you would in your inverse norm. It gives you everything there. You can find your critical value. Your critical values on your table 5, remember, are all positives. And if it's on the left-hand side, you make it a negative. If you use your T-test, which is fine by me, I like the calculator steps. And then, like I said, for some odd reason, I get half my class likes the calculator, half my class likes the formulas. So just tell me which one you use because the answers are slightly different. Your calculator is more exact than our tables and our rounding. It won't be that much, it won't be off enough to change your decision. That I know. they'll be in the ballpark. Questions? Everybody good with this? This is 19 points of your final.
Oh, it's good because I find it's a good way to get a lot.
It is a good way to get a lot because this is the one we spent a lot of time on and everybody did fairly well on this. Here's a proportion one. Proportion, percent, p hat. They all begin with a p. Advertise is that no more than, so it can't be more than that. It's got to be less than or equal to 10%. Make it a decimal. It took a random sample of 57 microwaves, and of those 57, 13 needed repairs. Now, if you use your calculator, you need an X, you need an N. You don't have an X, you have a p hat. This is your p hat. It's perfect for your formula because we need your p hat. For your calculator, you got to multiply 57 times 0.13, and you're going to have to round. You could either round to 7, well, I rounded to 7, or you could, if you rounded to 8, please let me know what you put in because it's different. As it is with the calculator, I think the answer came out to be 0.546 or something like that. With the calculator, it's different. Because don't forget, the calculator doesn't have to round. You just put in, you know, with the calculator, they're using your 7, whatever. When I'm putting it into formula, we're rounding that. We're being a little bit more exact. But you're putting either in a 7 or an 8. You can't put in a decimal. You put in a decimal, you get an error. If you use your formulas, and again, I gave you all the formulas to use, whichever one you want to do. It's not enough to change the decision that you made.
If you were to use the calculator, which one would you choose?
I choose 7. What did it come out to be? 7.1.
Oh no, I was just like which option?
Oh, which option?
Yeah.
You're going to choose your, this is a text. So you're going to find something that says proportion and test and a Z. God bless you.
Thank you.
So go to stat, go to test, and look for something that says proportion and z-test. See it? One proportion, z-test. Usually they're kind of grouped together. All your tests are together or your intervals are together. So when we hit the intervals, everything has an interval name. And here's your one proportion z interval that we did for confidence interval. So they're all up there. Okay? And again, make sure I get an interpretation. It's a good chunk of that problem to give me the interpretation.
Are you gonna have those?
The charts will be up, but they'll also be on your formula sheet.
Okay,
Did I put it on your formula sheet now?
possibly.
Yeah. Whatever your formula sheet is, you get that back.
Do you want us to give you our books tomorrow too?
Yeah, whatever it is, I'll take the books right off the shelf tomorrow. If it's not there, please bring it in.
Okay, so
And any calculators that you have, it's a good time for me to take that, and then I could tell anybody who's missing anything so that I can get it by Friday.
okay.
All right. Here's another one. Here's one with your standard deviation. Now the key here is if it's a standard deviation, you have to square it. If it's a variance, it's already squared. Your critical values again are on your chi test. This is a chi-square test. We're on table 6. Table 6 is area to the right. It's slightly skewed and it's always area to the right. Still start with this just like we do your inverse norm and just divide it out by 2. And then pick the 2 values. The smaller one goes on the left, the larger one goes on the right. Your formula is nice. It doesn't even need any of those. It needs the degrees of freedom, it needs your sample standard deviation, your sample and your population standard deviation. Your population standard deviation comes from your plane, because the plane is made about a population. There's no calculator set for this one. So just use your reject regions. Questions at all? Everybody's right on target here.
Failed rejection.
Fail to reject HO. You're falling right in the middle. Okay, here's a nice independent comparison of two things going on. We're comparing French fries at Burger King and French fries at Wendy's. This is great for what the statistics is meant for. It's, again, yours doesn't say population standard deviation, and I apologize. So that's why we know it's a z-test, a two-sample z-test. If you did a two-sample t, that's because you didn't see the word population there. So this is our two-sample z-test. Can you support the claim? Again, when they use the word support, you know it's an HA. When they say that the two fries are different, they're not the same. They're not equal. That's what different means. If they're the same, then they're equal. Make sure you label, my claim shouldn't be crossed out. I don't know where that line came from. But that's the claim. Make sure I get the claim, the HO, the HA. Make sure you clearly label everything for me, guys. My bracket's not labeled very well. Show me the calculator step. If you want to test p-val against the level of significance, that's fine too. If you want to test your z-score against the level of significance, that's fine. Okay. So there's enough evidence to support the claim that the fries are different at Burger King. Okay, your caloric content. And then the last one. This one is a t-score, is a t-test, a two-sample t-test. The two-sample t-test, the only thing you have to worry about is if your population variances are equal or not equal. If they're equal, you're going to pool the ends, and you're going to say pool yes on your calculator. Your degrees of freedom then are both of your ends, subtract 1, therefore we add them and subtract 2. Yet you need to get your critical values. Take it off your T already, and you should be fine. The T is nice because it kind of lines up X1, S1, N1, X2, S2, N2. It just asks you for pool, yes or no. If they're equal, you pool. If they're not, you say no pool, and you take the small n minus 1.